So now we have all of the tools to talk about different types of collisions. As we said before, the total momentum is always conserved if I have no external forces acting during the collision. So we can write out a general equation that is always true for collisions. So we know that the initial momentum is equal to the final momentum. And so if I have two objects colliding, this implies that I can write something like the mass of the first object times its initial velocity, and we'll just write these out as vectors, plus the mass of the second object times its initial velocity has to be equal to the mass of the first object times its final velocity plus the mass of the second object times its final velocity. That is always true. And so one of the things that we can write then is that if I want to look at the difference in momentum of these two objects, so let me group these things in such a way that all the mass 1s are together and all the mass 2s are together. So that means that I'm going to move, let's move mass, this term over to this side and this term over to this side. So if I do that, and then we'll write it like this. So I'm going to write mass 1 times V1 final minus mass 1 times V1 initial is equal to, and then I'll write this as mass 2 times V2 initial minus mass 2 times V2 final. Okay, and so these are not quite what we want to write. So let me leave this one as it is, and then say that this is equal to minus mass 2 V1 final, sorry, V2 final, minus mass 2 V2 initial. So I just factored out a minus sign, but it's important. So what this tells us then is that for any collision, this thing here is the change in momentum for object 1. And this is going to be equal to, this in parentheses is change in momentum for object 2. And so the consequence of the fact that momentum is always conserved is that the total, the sum of the two momenta has to be the same. So whatever momentum change we get in object 1 has to be equal and opposite to the change in momentum that object 2 undergoes. So this is a general principle that is always at work in any collision, as long, again, as there are no external forces. Okay, so we can always use this to talk about collisions. That's always true. Okay, so then we can talk about two other specific types of collisions. So the first one that we're going to talk about is an inelastic collision. And this is something that we already experienced. What this means is that the masses stick together, or objects, masses, stick together after they collide. So instead of having two objects rebounding and flying off away from each other, they stick. And so this is the collision that we just did with the two balls a second ago. And so in this case, we know that my original momentum is going to be equal to m1 times its original velocity plus m2 times its original velocity. And this is going to be equal to my final momentum. But in this case, they stick, so this is equal to m1 plus m2 times v final. The v final is common because they're stuck together, so they're both moving at the same speed. So one of the things that I can do is to solve for v final in terms of the initial conditions. So v final is going to be equal to m1 v1 initial plus m2 v2 initial divided by the sum of the masses, m1 plus m2. So that gives me the final velocity of the system. Now we've done this in vector form, which is correct. And usually this is needed. We'll have full two-dimensional collisions. We will probably stick to one-dimensional collisions moving forward, but this is the full vector notation. Now one of the things that you might recognize here is that this is actually the velocity of the center of mass of the system. You go back and look at how we defined that originally. So now this makes sense because if I have two objects and they stick together as one object, then their position necessarily is that of the center of mass because all of the mass is at one point. And so this final velocity tells me how fast that glommed object is moving at the end of the collision, which is basically how fast the center of mass of the system is moving because the system is now one object. So it has to be true that the final velocity of the system is equal to the velocity of the center of mass of the system. And we're going to use this concept next as well, but so that this is a nice lead into the next kind of collision that we're going to be talking about.